This is the Getting Started with R and Docker tutorial, just in case it's the first morning of the conference. I know people have flown in from all around the world. This is very much an introductory tutorial. Oh, my name's Elizabeth, by the way. And apologies for standing up here on a podium like I'm some, deity of Docker. I have been told I have to stand here because they're recording it. So please don't take this as any sign of hierarchy in this room. As I work through this, I'm going to be doing quite a bit of talking, especially in the first bit, to sort of introduce the concepts. So if you have questions, if you want me to go over something again, just chuck your hand up and we'll kind of go from there. Little bit of housekeeping for today. First thing is, so there are a handful, probably about 20 or 25 kind of exercise sheets, walkthroughs. I'll be walking through all the examples today, but the sheets that are floating around have a little bit of extra information because there's bound to be something I forget to say out loud, and a little bit of exercises that you can walk through. These are also available online on GitHub, but if there isn't enough of those exercise sheets for everyone, so introduce yourself to the person next to you and share. There's also a couple we'll be working today. So these talk slides will be available from our GitHub repo under Use Our Docker tutorial. Feel free to download them, work through them. I've put a lot more. Normally my talks are just basically cat GIFs and I talk to them. I've actually put content in these slides for you today because I figured that it would be good. I always find it's useful in these tutorials if you can actually go back to the slides afterwards and use them as a bit of a reference. So I've tried to load up the slides with a bit of content as well. So feel free to grab them and the exercise sheets in that repo as well. The exercise that we're going to sort of work through today is built off a couple of templates that I've built out in the Docker Hello GitHub repo. So if you have a GitHub account, it might be a good idea to kind of fork that now and download it, or just download the zip file. If you are having trouble, can I just get a show of hands of who has actually managed to get Docker installed, or maybe who hasn't managed to get Docker installed? Yep. Windows problems, no Mac problem. And my own colleague hasn't managed to get Docker installed because we bought the really old work laptop. So we will be floating around. Sorry, I should also introduce Dave, who's my helper today. Also the author of the Google Way package, so if in the background you've got some lingering spatial questions, chuck them at him. He will be wandering around as well as me in some of the more interactive bits, helping out. And there's also a break in the middle, so if you are having trouble getting stuff installed or you want a hand sort of working through some of the finer points, give me a yell. I'll also be working through the exercises up here, so even if you're really stuck, have a squiz at the laptop next to you or kind of work through the exercises. Hopefully it will be useful anyway. The other thing to say, the other two kind of things to admit, one's the first kind of confession. This is a Use R conference, but there is very little R in this tutorial. This tutorial is really about all the stuff that we can put around R to make it a bit more productionized, a bit more reproducible, able to do bigger and better things. So that's I realized about 3/4 of the way through pulling together these slides that there was very little R code in any of them, so I thought I'd better make that admission up front. The other thing is that this is a beginner's tutorial, so I'm going to work through a lot of the whys and the wherefores and the where you apply Docker, as well as doing some basic examples of kind of single container workflows. If you are already comfortable with Docker, you kind of know the basics and you're kind of looking for something a bit more a bit deeper, a bit more advanced. There is actually a slightly more advanced Docker tutorial going on about 3 doors down. I won't be offended if you want to get up and jump ship. Cool. All right, ready to get started?
Yeah.
Okay. Are you sure? 4 people are ready to get started. Are we ready to get started?
Yeah.
Yeah, awesome. Welcome to Brisbane, by the way. Who's from Australia? Who is suffering jet lag? Yeah. Very good. Brisbane is a very pretty city, so again, I won't be offended if you want to sneak out kind of just before the end and go for a nice walk along the river. That's a perfectly viable option. We've got a lot of talking coming up in the next few days. All right, let's get started. I figure I should probably introduce myself, which is always the hardest slide to write, right? Who am I? I am told I'm a data scientist. Apparently now I have a name, which is nice. What that actually means is that I'm more of a programmer, probably coming from that side than well, a mathematician these days. I started programming computers very young age in BASIC. My first computer program was written in BASIC, which probably shows my age. And at university, I wrote programs in Fortran. Fortran 90, not Fortran 77. And if anyone wants to buy me whiskey, I will still chew your ear off about how it's not that bad a programming language. I did computational mathematics at uni. I played with astrophysics and black holes. Got a bit sick of academia, and I've spent the last probably decade doing various things, from communicating and managing and also building out data science solutions. So the last 10 years I've kind of been fortunate enough to run a company that specialises in, well, I say we were data scientists before it was cool. We started off just wanting to solve problems with maths. So we started off as a little mathematical consultancy. We now we do analysis services for people, but we also build out tools for people as well. And I just want to tell you a little bit about that, because it's actually our story of how we've kind of grown as a company, and how I've kind of changed as an analyst is kind of also a nice story for how your workflow might grow to a point that you would need something like Docker. We have an office, Kelpie. For those of you who aren't from Australia, a Kelpie is an Australian sheepdog. She loves cuddles on the couch because she's now 13 years old, but she's still a maniac. And is a very important member of the team. But probably the more important stuff is that we work on analysis services. We provide tools for other teams, and we focus on, when people ask me what areas we work in, I actually say we don't target ads. We do everything but. So we work in transport, we work in environmental management, we work in kind of organisational analytics. If it's got numbers, we'll have a crack at it. We're also very keen R and open source advocates as well, which is one of the things that I like about both R and Docker. And as we've grown, so over the last, over a decade, we've used a lot of different languages and a lot of different tools, but R has been probably our go-to language for most of that time, just because of its flexibility and ability to wrap other languages in it and do stuff, get stuff up and running very quickly. And when I think about how we've kind of changed, the deep past was sort of using R or Excel to do analysis for people and delivering them big fat word reports of the answer. Till there kind of came a day that I think I said I never want to see or write or be involved with another VBA script again ever in my life. And I can hear the solidarity in the room there. So then we kind of moved to more R scripts, and that was nice. We kind of brought in some processes around scripting, which allowed us to kind of, at least within the office, have our reproducible workflows. But we were still delivering stuff in Word because it was still the best tool, and you would try and do something else like in LaTeX, but then your client would say, can I have the Word document? And it was... until I reached a point where I said I never want to open another Word document in my life. It took a little while to get around that until we we hired Alex. We hired a graduate about 18 months ago, and one of his first jobs was to prepare a Word document, and he came to me and went, can I please investigate Bookdown? I said, go for it. So we've been using, now we kind of have as much of our workflow as possible actually scripted. So we have processes for R scripts, for internal manuscripts. We use Bookdown, we use Shiny, we use Sharingan. Awesome slides, Sharingan package, get into it. It's very cool flexible package. And now I never have to use PowerPoint again. So this has kind of been our journey, and as we've gone on, the thing that's kind of pushed it at each point is the need for reproducibility and the need for doing bigger and better analysis. So spending as much time as possible on the actual analysis and cutting down the time we spend doing data wrangling, doing fiddling around with tables in Word, that kind of stuff. And the reason I kind of tell you all of that is because I think it's kind of a typical analyst sort of story. So who here is, I'm going to ask a question just in case, who here is not a regular R user? Okay, cool. Okay, awesome. Who here is a student, so uses R in kind of a student context? Yep. Less than I thought. Who here is using R sort of day to day in a commercial setting at work? You come to the right tutorial, because that's the place that this is really, really good. Nothing against the students. This is also a good workflow for students, and it's a pretty cool thing to have on your CV when you stop being a student. The typical analyst kind of story, even if you're working in a commercial setting, a lot of times you're still the one analyst in the corner. Right? Who's the one analyst in the corner? Or the couple of, who's actually working on a big development team? In the middle. Yeah, I'm interested in the hands that are in the middle there. Oftentimes though, there's this flow where someone will come to you and say, I've got this data. What the hell does it mean? And you've got your little R set up and it's fine. You've got your environment variables all set up. It's all set up for you. You know it well. You pull in data from anywhere, from databases, from files, and you can pretty much pull in any data from anywhere in R. It's nice. And you can use that system to do your ad hoc analysis. So typical workflow, you get your big pile of data, you use your environment, you play around with it, you figure out what's going on, run some models to check what's actually going on, and then you deliver this out. So it might be shinies, it might be reports. Who's regularly sort of preparing kind of business reports using R? Yeah, sometimes. Who's regularly doing shiny apps and that kind of stuff? Cool. Who prepares kind of data pipelines? So you spit out, okay, good, everyone. We all end up doing everything, don't we? Because it's, yeah. But we got this kind of idea that we're going to do all this and then we're going to pick out the story and then we're going to deliver the story to whoever it is, our stakeholder, dude in a green shirt. That's not the end of the story, and I'm sure most of you know that's not the end of the story. What happens then is that people get curious and they go, oh, that was really cool. Could you tell me more? What if we just change that thing? Or, oh, I think actually maybe it's over here. Can we go and explore that thing? Or they go, that's fantastic. I just need these 3 bits of it to take to the executive and I'd like that to be a report that runs every month. Or that data set is awesome. Can I please have 3 versions of that every week with slightly different inputs? What else do people say? Oh, we had one the other week, which was literally, we'd done this analysis for a client. It was a looking at wind resources. It was a wind farm, developing a wind farm. So looking at wind resources and spot pricing and stuff. We did this analysis 4 years ago, maybe 5 years ago. It then sat there while they waited for the banks to get themselves together. And they came back to us 2 weeks ago to say, can you run that analysis again, exactly the same, but now we want you to also run this comparison analysis side by side and do a whole lot of stuff. So that's a use case that happens quite often for us. Things shouldn't go out unless they're being reviewed by someone else. So it's not we don't use form pair programming because like introverts, you know, don't sit there, don't make me sit there and talk to you for hours and hours looking at your code. But we do quite reasonable reviews. So it will be, before we send this out, can someone else just sit down and run through it. And what you often find is that you're sharing stuff between people and everyone had that thing in R where you download a tutorial or you're looking at someone else's work and instead of actually diving into it, it spends you like 4 hours setting up all the libraries because they use some development version of something. Not looking for any hands at all in the office. Oh yeah, that's the version 6.7 of GitHub from 8 months ago, because that's the only one ago. So there are a whole bunch of difficult things. Have I missed any? You know, these pain points, things that I've said a couple, yeah. A couple of really big ones anyway, so I want to talk to you guys in a break. You know what I'm talking about. So these are the things where there's also a thing where you might want to try out some development ideas yourself. If you're running a Shiny and you've got it deployed to a website somewhere or on an intranet, and you actually want to have a play with it, you don't want to go in and test in production. You don't want to be kind of playing around in that actual code. But how do you actually manage that giant mess that is everyone's development folder with the nice clean, this is what we're going to package up for everybody else? And too often, I mean, we spend a lot of time in our office talking about this and trying to get it right, but too often it still kind of looks like this. So it's fighting and wrangling. So I say to people, data science is like 90% data wrangling and 8% struggling with libraries and frameworks, and then 2%, ooh, cool. So we want to get to the ooh, cool bit more often. And I think the kind of philosophical underpinnings of all of this is that being an analyst / data scientist on your own is not enough. And that's what we have found in our office. And it's not just because I have I am more from a programming kind of point of view that I've pushed it, but it's not enough to just manage this. You need tools outside of R. And I think it comes back to this idea of there's kind of two types of data scientists. Has anyone sort of seen this definition floating around? It's been floating around on the web for a while, and it's not perfect, but it's actually useful for our conversation today. You know, not all models are wrong, but some are useful. This is a useful model, I think. And I think most R users that I've met probably fall into the analyst type. So that you're wrangling data, you're building models, you're designing reports. When I speak to people who come from a computer science background or a DevOps background or whatever, they're more of the builder type. So these are the guys typically that are running kind of chucking in some computer vision model in behind a mobile app to tell you, you know, what things you can do around Brisbane from a picture. These skills are much more, these guys are sort of programmers that can do maths, these guys are mathematicians that can do better programming. And often we're more in that space. But I'm here to tell you that if I never, I hate the word unicorn, right? I don't know how many conferences I've been to in the last decade that have mentioned this word unicorn. And my answer is always, yeah, no one is a unicorn on their own. And in fact, we need our data science tools, we need our R analysts. But your R skills and your analyst skills aren't the kind of DevOps skills that you maybe need to just make this stuff run. Everyone is familiar with the phrase DevOps? Do I need to explain what that is? Yeah, okay, cool. So we're kind of looking at what are the developer tools that we can use to beef up R, and that was kind of my starting point for actually writing this tutorial. And there are quite a few that you can use without even leaving the R environment. There's the R projects is actually probably not a bad place to start. I don't use R projects an awful lot, but they're quite a nice way of packaging up work. A step beyond that is packages. So who's written their own R package at some point? Full coverage with unit tests, with test this? Yeah, hey, I've got a nod down the back, cool. We try, and it's actually a really good practice, right? It's one of those practices that, geez, it's a pain in the butt, but it is actually a really good practice. So the idea of unit tests is that, and the idea of packages is that you package up your commonly used functions into little modules that you can put in anywhere. The idea of a unit test is to protect you against that thing where you change something in 6 months' time and then all of a sudden the world breaks. So they're little tests that you write around those functions to make sure that your code is still doing what you think it's doing. Computer programs are awesome, but they do tend to do what you told them to do, which is not always what you meant. But moving beyond that, like even personally, I found a bunch of other tools that are really worth getting your head around if you're working in R all the time or working on big models. First one is probably GitHub. Who has a GitHub account? Who doesn't have a GitHub account? Oh, sorry, I shouldn't have just, See, this is why I like actually being down in there. Who has a GitHub account? Most people? Yeah, cool. So I don't need to probably tell you why that's a useful thing. Particularly useful for version control. We use GitHub for code management. We use actually SVN, which is an older, more file-based version for all of our projects, so everything we do is version controlled. And there is nothing like having to sit there for an afternoon working out a conflict to make you understand the importance of version control and code management. In fact, we actually gone so far that a couple of our clients were actually training them up on how to use GitHub because it was just this disaster zone where we would hand them over this code and then 6 months later they would come back to us, and none of them are in the audience, I won't name names, but disaster zone. So there's a couple that we are actually sharing the joys of actually having version control and documentation on when code changes. Master data management, so I'm not talking just about putting stuff in databases, though that is a nice place to start rather than having a million files. But it's also actually data pipelines. So again, this is partly for your own life. So you get a new data set, you can just push a button and it goes through and has tests all the way through to tell you where it's different to how it was before. It's also really nice if you're dealing with data custodians that you don't have any control over, so clients, people in other departments. It's really nice to go, I'm going to really help you, and you're going to upload this file or give me this file, and then I'm going to give you back a bunch of logic checks that tell you where you need to change the file. It's nice. And teams and projects, we use a bunch of stuff to actually keep ourselves on track with managing multiple projects with a small team. Slack, Trello, Clubhouse. If people haven't used Clubhouse, it's like Trello, but it has like an actual workflow built in the back end. It's like a nice in between Trello and Jira, sort of in betweeny. And GitHub projects and wikis. So there's lots of tools that you're probably already familiar with. The one I want to talk about today is specifically about deployment and code bundles. So this is the Docker bit. Who has actually used Docker before, other than just going run hello? Okay, so we're all starting from a couple of hands went half up. I don't know quite how to interpret that. The idea of Docker, and the reason I'm kind of doing a bit of talking up the front of this tutorial today, is because Docker is one of those technologies where it's reasonably easy to grab a prepackaged tutorial or grab a prepackaged container, run a few lines of code, and hey, I've got a Docker container. But unless you actually understand some of the underpinnings of how those things go together, how they might interact with your code, for starters, there's very few examples written in R online. And also, it becomes really easy to end up with a 6 gigabyte container that you can't transfer anywhere or do anything with. And so we're going to dig into some of those underpinnings today so that you can go and do whatever you want to do. But the basic concept of Docker is that instead of handing over to someone, say, an R script, you hand over an R app. And this is even beyond, you can think of an R app as being, say, a Shiny. But again, it's not just handing over a folder that's got a server.r and a UI.r in it. You're handing over all of the environment variables that go along with that, any setup. So basically, I hand you a Docker image, you go run, and you've got a script runs, a Shiny app happens, something happens in there, you can log in and use it. It's also, so it's really, really nice for packaging up environments. If I just need a machine that's got all of the geospatial stuff on it to do something with, I can just get one and set it up within 5 minutes. If I've got to deploy, about probably a year ago, we were doing some work for a client that needed, we built a model for them to forecast their workforce in the future, and we built a whole lot of Shiny apps to go along with it to allow them to kind of explore, what their data was doing. quite sensitive data, so HR data and health data, so we didn't want to put it in the cloud. Involving their IT would have taken 3 years. So we needed to deploy it on kind of Windows laptops and Windows machines. And this was actually one of the, that job was actually one of the motivations for really, we didn't use Docker on that job. And the fact that we didn't caused us a lot of pain and suffering was actually one of the motivations for doing it, because there was a lot of time configuring Windows laptops to do stuff that they weren't actually designed to do. You'll notice here a couple of things. So I've still got this person kind of doing their ad hoc analysis out on the side. So that is one kind of workflow where you have your own environment set up and then you move the bits you want and bundle them up. You can also just do the whole thing in sort of different containers. So you can have a big, messy, ugly dev container, and then you basically have another container that's lightweight that you kind of use your production code. You notice also that the data is outside the container. I'm going to talk about that, but just keep that in your head, that the data lives outside the container. So what is Docker? Well, Docker is a bunch of penguins and octopuses that live in your system. No. I can't figure out if this guy here is like the controller who's doing stuff, or if he's like a security breach as well. This is the official picture from the Docker webpage, by the way. So this is how they explain it, which doesn't necessarily fill you with a lot of confidence. For technical people, who's heard of a virtual machine, or who's used a virtual machine? Okay, so in the beginning, there were bare metal actual servers that we would install apps on. One whole computer sitting in a cupboard somewhere running one piece of software is not very efficient. So the next step from that was a virtual machine. So in a virtual machine, you have a host computer here. You have all the infrastructure, the physical infrastructure of that host computer, and you have basically the virtual machine is an entire computer within that computer. So it's an entire operating system. It's all the libraries you need. It's all the apps that you put over the front. And it uses this thing called a hypervisor to actually which are like the drivers, to actually manage the host machine. Quite big, quite unwieldy. There are some security problems with it. Containers are a much more lightweight version of that. So you have a host machine, you have your infrastructure, you have all of your host OS kernel, so all of the core drivers and stuff that run your kernel, that run your operating machine. Then you have this Docker layer that sits on top of it. And basically in your container, all you have is a bunch of libraries and your application. So you may be running a Windows machine, you may download an Ubuntu container. It looks like you're using Ubuntu, but actually you're still using all of the Windows guts underneath it. You've just got all of the kind of upper level libraries. Where that's kind of nice is if you've got things like if you're using, say, TensorFlow, or you're using GPU computing, so you can have this set up, your host machine set up with all of its NVIDIA drivers and all of its stuff. And here you basically just talk to it. You don't need to, at each step, kind of configure all that. So this is much more lightweight. You can kind of get up and running immediately. It's sort of easier to configure. You don't have to configure an entire OS. You just chuck what you need in it. Often, so if you're deploying this stuff, like say in Amazon Web Services, what you're actually doing is you're getting a virtual machine and then you're putting a bunch of containers on it. And that kind of ability to do that allows you to build giant kind of things, you know. Pokemon Go was built entirely in not in Docker, but in Kubernetes, so entirely sort of serverless on the Google framework using this stuff. That is beyond the scope of this tutorial. We're not going to be doing Pokemon Go today, but you can kind of see you can get really, if you're working with it on the IT side of things, it can get quite big. So some definitions. An image. So when I talk about a Docker image or a container image, and I should say Docker is just a particular flavour of a container. I just mentioned Kubernetes, it's another. If you get your head around one, the rest is just syntax, right? So we're just going to talk about Docker today because it's probably the granddaddy of the containers. It's probably the most mature. And An image is just a self-contained executable bundle of code, settings, environment variables that are used to run the code. So you can think of it as a bundled set of R scripts. It's actually, and it's got R scripts, it's got your environment variables, and it's got controllers to actually turn it into something. So it's like, you know, excel.exe. That's your image. The container itself is a single running image of the image bundle. So when I say Docker run my awesome container and I get a Shiny server, that instance of the Shiny server is a container. If I then go Docker stop, that container, it's disappeared, it's gone, it's dead to us, it's never to be seen again. I need to spin up a new one. The Docker file is what we're going to spend a lot of time working with today. The Docker file is the control script that compiles everything into the image. So for those of you who are fellow kind of builder type data scientists, you can think of a Docker image as like a class definition, essentially. The Docker container is like an instance of that class, and the Docker file is the kind of control script or the make file that puts it all together. If you don't take away anything else from today, take away this. Containers are ephemeral. So let's say if you run Docker start, you get an awesome Shiny app. Your users input their data into that Shiny app. It gets saved in a .data file within that Shiny app. You then go Docker stop. That data is gone. It's gone. Don't email me in 8 months' time going, where's my data? It's gone, right? Say it with me. It'll be gone. Yeah. They're ephemeral. They will stop. Which is why in that picture before, I showed you it had the container infrastructure and then it had the data sitting outside. So if you want to save the data, you need to either use a special kind of data container or your physical file system back on the host. All right. I'm going to work through some actual examples of some stuff. And we're going to have a little play to convince ourselves that the first bit is quite straightforward. So this is the install page for Docker. There were a few people that didn't have it installed. So when we actually get to the bit where I can't help you in your bias problem, that's beyond me. There's some other people I might be able to help with when we kind of get to the exercise bit of it. But for now, yes, I'm told you now need a login to download, which is see, I just used apt-get. I didn't do any. Yeah. So basically, the Docker website is actually really good in terms of open source packages and environments. It's actually quite a good website. So go to here, download your preferred package and go from there. I can give people a hand with that later if I'm allowed to leave the stage for 5 minutes to wander around when we're doing the exercises or during coffee. If anyone, this is a slight little technical bit, which is mainly in the slides, so when people are looking at them afterwards, they know it. If anyone has installed this on Linux, you'll notice that when I do the commands and I go like Docker run, you need to put a sudo in front of it. Just technical note on that, because it is important if you're going to set this up somewhere where it's a joint or shared machine. Docker actually connects to what's called a socket. And that means that when you have control of a Docker, when you set up a container, you can set it up into your root directory on Linux, which is not normally a thing you can access at all. So people who are allowed to build and run Dockers on a Linux machine can get root access to that machine. So Linux by default requires you to use sudo to do that, because then it's logged. If you do what they say on the Docker website and set up a Docker group, what you're doing is you're saying anyone who uses this machine can have unlogged, unpassword protected access to my root machine. Just be aware of that. These guys have a really good article about a slightly better way to do it. If you read it and you go, that stuff's beyond me, just type sudo. Trust me. I have changed my laptop, so I don't need it, but the work server that is the shared computer at work needs sudo to run it. Sorry, that was just a little bit of a technical aside, but an important technical aside. So let's look at some basic Docker commands. So those of you that actually have this running on your system, hopefully, I'm going to see if I can see if I can you still see that on the right-hand side, or is that stretching the bounds of friendship for people up the back? I want to actually run through some of this. So you'll notice, actually let me just get a new terminal. Okay, so what happens when we actually run Docker? Got black on black on black with bright lights, so just bear with me. Okay, let's get started. Docker, righto. It's normal Linux thing of saying you've just typed in a command. 2 seconds. All right, so it basically gives you a list of all the things that you can do. We're not going to go through all of the Docker commands today. As you can appreciate, some of them are quite advanced. We're just going to cover the basics. So the easiest thing to do is to try and get your mouse to stop being crazy. The easiest thing to do to check that you've got Docker running, oh, for goodness sake, I don't want a pop-up window. Uh-oh. Hang on a minute. Have I just crashed my computer in the middle of a tutorial? Good grief. All right, I'm not going to do that walkthrough. Are you serious? Okay, I can do this, but I can't get input from my trackpad. Awesome, Ubuntu. You are getting an upgrade to 18.4 tonight. Right, that is that. I've had enough. Okay, let me just try to... All right, there's only a few more slides before the break, so I'm going to just go through them in this, if that's okay. Basically what I wanted to show, this is actually why I've put the snapshots on here. So what we can do, I can't do anything. Docker container, so if you run, you'll notice here, if you run docker image ls, it'll give you a list of all the images on your machine. So if you manage to download the Hello World Docker the other day, you'll get a list, you'll get something called Hello World. If you manage to download the Rocker RStudio, you'll get that listed. So they're all the executables that you've got. If you do Docker container ls, you'll probably see you've got nothing running. Docker PS is also a bit of a shortcut, just shows you for those people who are avid users of kind of Git and / command line in Linux, will probably find most of these commands reasonably comfortable. So you can get a list of the images you've got available, you can get a list of all the containers that are running. The first thing you want to do is run docker run hello world, and because I have had every single presentation disaster that has ever happened, I'm sorry that this is really small. Let me read what you get. So most of you have got Docker running, run hello. Okay, so you'll see it tells you what it's doing. It took the following steps. It contacted the Docker daemon. Awesome. The Docker daemon pulled the hello world image from the Docker hub. The Docker daemon created a new container, and it streamed that output to the Docker client. So again, those of you who are running Linux, that probably all makes sense. To those of you perhaps are Windows head, perhaps not. So I'm just going to show you a picture of what's actually happening there. So you've got your Docker host, you've got your, in this case, your laptop. It's running the controller, the Docker daemon. When you go Docker pull, it sends on your machine, it sends a message to the Docker daemon to go to a registry. In this case, Docker Hub is just the registry that Docker runs. Grabs that image and puts it on your machine. When you go Docker run, it sends a message to execute it pulls that back and puts it on your machine. When you press Docker run, it gives a run that executable, so make it actually happen. That's basically what's happening. So when we talk about images, you'll find if you do, the first time you run hello world, it will say I'm getting this from the registry, because you go run, it goes, oh, I can't find it anywhere here local on my local library. I'm going to get it from Docker Hub. After that point, it will just run it again from your local machine. So A registry is just the repository of images that's stored somewhere in the cloud. Docker Hub is Docker's own registry, and tags. So you'll often refer to an image, or you'll see like RStudio : latest, or RStudio : 3.5. So we can version our own images, and we can pull different versions of images. So that's what that tag is that we stick on the end. And your basic commands that can do like probably 85% of stuff with Docker pull, Docker build, Docker run. So Docker Hub itself, this is, okay, have I got? Everyone type hub.docker.com.explore into their web browser. I'm going to need to reboot this, aren't I? I'm not going to be able to save this. I'm going to need to reboot it. I don't think I can do anything. Jeez Louise. See, so much for my dissing Windows. So if you go to Docker Hub, and I do actually want to, and we're off, coffee is 10 to 10:30, or was it 10:30 to 11? 10:30 to 11, yeah, so I've got, all right, we're going to reboot. Should we reboot? Yeah. All right. Go to Docker Hub while I'm doing that, and you'll see. Anyone got any questions at this point? That might be a good point. Just go to hub, whatever you said, hub.docker.com, yeah. Yeah, and you'll find it. Sometimes. Yeah, it's one of those technologies where, sorry, the question was how much complexity does it sort of add to your workflow to run stuff in a container versus just on bare metal. So a situation where, for example, you want to try out something, you know, on a oh wow, okay, hang on, are we now, can I now, okay, cool, I have everything back. Sorry, I'm going to answer your question in 2 seconds. Just going to get myself back up and running. A situation where, for example, I want to run something online and I need all of the geospatial libraries, it's great because I can just go docker build Rocker geospatial, and within like 5 minutes I have everything running rather than sitting there and trying to install RGeos and all that stuff. But at the same time we've actually had, I played quite a bit because when I kind of first got into this I went, Docker, everything goes in containers now guys, and they all just sort of looked at me. And I tried that principle for a couple of our online Shiny app demos. What I've ended up doing with a lot of that, we put a lot of that stuff just on shinyapps.io because it's just like 4 lines of code rather than actually configuring that stuff. So you can add complexity when you start to build apps. So when you start to have your app running and a front end and a back end and a this and a that, that's where it starts to get complex and you start running into some of the more development bits of it. All right, we're back. And we're gonna, where did you just go? I'm gonna put you down here. And we're gonna go back. Ooh, okay. Awesome. So, oh no, yeah. Docker Hub, it's awesome. Seamless integration of different things I'm trying to do. Okay, the thing I wanted to point out about Docker Hub itself is that it's obviously not just R. And you can notice things like Ubuntu. So there are also, I believe, Windows Dockers now. I haven't played with any of the Windows containers, so I am actually interested to, because we develop on Mac and on Linux, so none of our clients, they're all on Windows, so it might be handy to kind of have that virtual environment to play with. The same goes the other way though. If you're on Linux, if you're on Windows and you just need a bit of Linux time, you can get that. You can just download the Ubuntu. You can also do stuff like download and set up like MySQL, Mongo, database servers. Remember my point before about being ephemeral? You need to set these up with your data somewhere else. These just provide the basic app. But that's actually a nice thing if you need a database for a client, or you want to figure out if you want a database for this thing, or you just want to test it but you're not allowed to put it on the company. You know, you can't get access. You've got to go through 14 firewalls and a dragon to get into the actual enterprise data warehouse. You can just spin up a local MySQL server and play and get it all kind of working before you take your 14 forms to IT. I'm not that cynical about, you know, the corporate world. You notice also these are all official. So Docker is open source. There are quite a few official packages and libraries, but there are a vast majority that are public. So my way when I'm looking for something to use, a container to use, is I go to, if you can find an official one, great. If you can, or if it's a public one, same as any open source, like you kind of want the public ones that have been downloaded a gajillion times, not the ones that have come from some weird country you've never heard of and that have been downloaded like 5 times. You just be careful. So the Docker file itself, so that's what's happening when it's contacting the Docker daemon and it's pulling it. Then it creates a new container, and this is the bit where it gets fun. So most of the Docker Hub repos, you can find the source on GitHub. So this is the Hello World, a portion of the Hello World library. There's obviously Hello World versions for all different kinds of architectures. The Hello World one that you just ran has a Docker file and a C executable called hello. And the Docker file is the most beautiful, sweet little makefile you've ever seen in your entire life. From Scratch. Scratch is a particular Docker image that is basically bare bones, just what you put in it. Copy hello into the / directory and command run hello. Too easy, right? So we're totally going to build these. It gets more complicated than that though, and here's the R bit. R is where it starts to get more complicated. So the Rocker libraries, they're not official, but they are very well supported. So if you go to the Rocker project, you will see every single flavour and version of R that you could ever imagine. The ones that are particularly useful for us, if I jump back into my talk. So if we have a look at the R version stack, so you can get any version of R, which is sometimes a helpful thing, right? You just actually need to go back to something that you were doing 2 years ago and figure out what's changed in between. You can get reproducible builds to fixed versions of R. And this is where the tags come in. So you can get kind of a particular version of the tidyverse, or you can get a particular version of the base R. And you'll notice here, sort of starts with the R ver, which is that particular version. It's quite a small image. It's 221 megabyte, 8 layers. I'll tell you what that means in a minute. You can go a step above that and you can get RStudio on top of that. You can get tidyverse on top of that. You can get verse, which is all the book down and those libraries as well. Geospatial then sits on top of that as well. So if we have a look at the Docker file for rverse, you kind of start to see how it all comes together. Is this the right one or do I need to? Yep, okay. So again, you've got a from. So this kind of this is where the sort of power starts to come out, because you can actually stack containers on top of other containers. So I don't need to do an Ubuntu or a Linux install just to get my R running. I can just grab that container. So this is from one of the Debian containers. Chucks a label on it, put some arguments on it, set some environment variables. These are Linux environment variables, not R environment variables. And then it runs a whole heap of Linux commands. So this basically is installing all the stuff in the back end. You'll notice that it's using this kind of continuation and then using the and, so it's running one after the other. I'll show you a better version of that in the next Docker file, but just keep that in your head at the moment. But you see, so it does run all the things that you would normally spend a half a day setting up, especially if you're the person in the office that's the token Linux person. You know, it's so good. And then it runs R. That's the command. So you'll notice here, this has got 1 command, 2, 3, 4, 5, 6, 7. So each one of those specific commands is another layer in the Docker file. So if I make a change in here, it doesn't rerun all of them and rebuild them. It just runs from then on. So you have this like little stacked within the Docker file, which is why when you come back to back a page, back another page, perhaps, you can see that somewhere in here, you can see that it had 8 layers. So there's sort of 1 layer for each command and, I don't know, 1 for the road, 1 for putting it all together, I believe. And so you kind of start to see one of the issues with just actually grabbing stuff that's got everything and the kitchen sink in it. So there's quite a big jump from just something that runs the base R and RStudio to something that runs all of the tidyverse. This is why when I was sort of putting this together, I was thinking, do I actually take you into all this detail, or do I just sort of show you some stuff and start building stuff? I thought, no, I actually want to take you into some of this detail, because you can, once you can build, if you only need one function out of dplyr, you don't need to grab the tidyverse image if you know how to build your own Docker files and put them together. The other one I wanted to show you, what was the other one I wanted to show you? Yes, the RStudio one, just quickly. So this is the next level up. It builds on that base R version. Set some environment variables, and you'll see here, the Linux people again, what this is doing here, and anyone that's ever installed RStudio on Linux will know what these commands are. So to install RStudio on Linux, you do a get, so you pull down the RStudio image, you run that package, and then you remove that image. So by chaining it to get, if I had these as separate run commands, it would download it, save that as a layer, do the next thing, save that as a layer, and then the RM kind of doesn't do anything. So by chaining them together like that, you don't end up with this extra stuff hanging around in your Docker file. Which is not too big a deal when you sort of start to get running, but you can see by the time you kind of build it up, you can end up with something. The geospatial container is about 1.5 gigs. So, you know, you start pulling that down over Wi-Fi for a talk or something, it's crazy. And so essentially, that's all it is, essentially, right? That's all it is to build up an image. Not essentially, there's like 2 more hours where that's what we're going to be doing. But we start from a base image. So that's always the first line. We copy files onto that base image, or we run. Often there's a from, and then a run a bunch of Linux stuff that you might need it to do. Then a copy whatever you need, whatever your actual files are, over onto that image. Some environment variables, so often you need to set a user because you don't want to run everything as root. By default, when you're in the Docker, you are the root user. Often you don't actually want that. And the Docker file lives in the top of your project tree normally. And to make life easy for yourself, just call it Docker file with a capital D. You could call it different names, but then you've got to remember all the settings to get it to just use the defaults. And the build command, when you go Docker build, it includes all the files and the folders underneath that working directory into the image build context, so into the app. So even if you haven't explicitly copied it over into your container, if you're running it in, and I say this from bitter experience, trying to go build and then going, oh, that's not going to work, on a giant development folder, and 20 minutes later with my cup of tea going, why is that taking so long? Oh, that's right, because it was trying to put like 6 gig into a container that I really wasn't going to use. So yeah, the build context. You can use Docker ignore. Oh, firstly, who builds a cat door that small? Like, I'd like to know what was going on here. And secondly, look at the look the cat gives the door. It's like, excuse me? And the Docker ignore file, you use that to exclude any unnecessary files. So this is a nice thing if you do have the giant development folder with 700 gigabytes of stuff. You can use Docker ignore to just go, ignore folder with all the crap in it. And limit your install packages to just the necessary ones too. Like, yeah, it's sort of nice to go library tidyverse, but it's rarely a necessary thing. And just a second reminder, A, because I love this GIF, and B, it's just really important. Dockers are ephemeral, so don't copy your giant data folder over there if you're going to be doing and changing things. Okay. All right, let's build. So we're going to work with the Hello World GitHub repo that I built. So if you are able to grab that, just grab it. Grab it now. I probably suggest you fork it, because if you see any, that way you can build your own version of it. And if you have any changes or things that I've gotten wrong, please just submit a pull request and we can go from there. So this is a little bit more complicated than the Hello World, not as complicated as the Rocker files, because we're using them. This also has that exercises sheet in there too, so if you don't have a physical copy of that sheet, you can follow along here. What is in this repository? So if you download this repository, you'll find an analysis folder that has, the most complicated piece of R code I've ever written in my life, right? So what this does is it reads in data from the data directory, it kind of R-binds it to itself and it writes it out again. Deep, meaningful stuff. That's the R though, so like enjoy that. That is the R component of this R tutorial. The data folder has input, CSV, again, like complicated piece of kit there. And then I have a Docker file which has got lots of words in it, so it's really kind of hopefully easy to follow along. So I'm going to be using the Rocker RStudio, which is why I said if you were able to download that beforehand, it's kind of handy, because I don't know how the free Wi-Fi is going to go pulling down. I'm not pulling down the giant Rocker stuff, but RStudio is kind of hefty enough. So it starts from that. So what we're doing is we're building, starting from a place that's got RBase, and that's got an RStudio server. And that's probably the most common image that I use, because it's sort of also nice to be able to go in and just tinker with stuff. I'm going to copy requirements.r. Oh, I'll show you what's in that in a minute. Requirements.r in Docker config. So this is just an R script, and I'm just going to install packages, and I'm going to install Datatable because Datatable rocks. Datatable fans in the audience? Yeah, the big data people. Just for fun, to show you the principle of it. So what we're going to do is we're going to copy. So this copy script, it copies from your local machine onto the Docker, and you notice it's putting it in /temp. You can put stuff, all of these commands within the container. You are a god, you are a super user. You can put stuff anywhere and do anything. And then you're going to install those required libs on the container. So it just basically run that script using our script. I'm going to create a R user called RStudio so we can log in to our RStudio server. By default, this image has RStudio as both the user and the password. Probably a good idea to change those, especially if you're using it somewhere where you actually don't want everyone to be able to just log in. And then we're going to copy across. So the reason we set that environment user, or the other thing is, things happen in the order you specify them in the Docker file, right? So we specify that R user is RStudio, and then I can use that $user to basically put that into home RStudio analysis in the Docker file. And we're going to copy it across. Should I see if I can break my machine again by actually building this thing? Let's see. Like I ran this 4 times yesterday without any problems, so let's see if we can make this all work. Okay. GitHub. So to build it, I don't know how long I've spent programming and talking. It's like literally my entire career has been programming and talking, and I still can't do both at the same time. It's ridiculous. So we're going to build. So to build, docker build, or sudo docker build. This RM and force RM, as it builds those layers, it just gives it basically the ability to remove any kind of unwanted layers that you don't want to hang around. It's just a nice thing for tidiness. -T means we're going to tag it. So you can tag it with anything you want, right? You can call it my most awesome container, my most awesome image. So this is the bit where we're building the image. So we normally tag them using something like, Symbolix / so I know that they're our containers or our images. And the little dot says build in this directory, please. So if I copy this and I paste it, should see what happens. Okay, now I have pre-run this, so I didn't need to sit here and wait for Wi-Fi to show you guys what's going on. But essentially you build from Rocker RStudio, so you see that's my first layer, copy stuff across using cache. So this is one of the nice things. So once you build this a couple of times, it actually becomes really easy to tinker because you can just make little changes and it'll just rebuild that bit. Run the R script, so it runs through in each one of these layers, successfully built it. So to run it, all we need to do is get my mouse to work. Paste. So first time I'm running it, I'm doing like the super simple version. Sudo docker run -D, so there's basically 2 ways you can run a container. -D means run it as a daemon, run it in the background. So this will run an RStudio server. You can't log into it though. The other way to run it is using IT, which is an interactive shell. I'll show you that in a minute. But run it in the background. RM just means when I exit from it, kill it. This here map support, so if any of you have used RStudio server, it typically uses 8787 as the port. We're going to say, if you happen to be using a computer that also has, on your host machine, RStudio server, you might want to run it on a slightly different port. So that's going to say, I'm going to access it through 28787 on my host machine. It's going to hook into that port. I'm going to give it a name so I can find it in my list because, my hundreds of containers I'm running here today. And that's the image I'm going to use. So that runs, password, it should work. Okay, so it's running. And now if I do a docker ps, it's running. And if I go over here to, let's pick one of these, 27.0.0.1, what do I call it, 28787? Yeah! And I've just used all the defaults. I think, I'm pretty safe from a hacker attack just at the moment. We can log in. And you can see that you've got our analysis, hello world, is running. I got a permission denied. So there's some problems here, and these are on your Excel sheet, on your exercise sheet. So can I just get a show of hands of people who've actually got this up and running and able to work with it? A few people here and there. My aim here was to give you guys kind of, 20 minutes before coffee to sort of have a play and to work through some of these exercises. Is that a good idea, or should I keep working through? So show of hands, play on my own, please. Show of hands, keep walking through. Oh, show of hands, can I just have a coffee? Or no preference, yeah. Yeah, I'm that one. So I might walk through some examples, but and then I'll walk through some examples for a few more minutes to show you stuff. But if you want to ignore me and just kind of play with the exercises, yeah, go for it. That's what I would totally be doing right now. The other thing I will show you here, the other way you can run it, which is, and let's just map it to a different port this time. So I can run it in interactive mode. And this is sometimes if you have problems with libraries didn't install properly, or you actually want to log in and have a play and see what's going on, want to physically log in and work with the machine. I'm going to call it Hello World Interactive. And so this is running it in interactive mode, and you have to tell it what command to run when you run it in interactive mode. So I just want a login shell, so I'm just going to go bin bash. Right, now I'm in the container, and I'm in the root directory of the container, so I can change to my home directory. No, I can't, because I can't type. And I can see here I've got the files that I had before. So I find this handy, because sometimes you are building a container and it doesn't install something, but you kind of can't figure out what's going on. Or you're getting some kind of weird permissions problem. Ugh. So you can log in here and you can actually build, because this is built on RStudio, which is built on RBase, you can log in and get yourself an RBase. And you can do things like, well, actually, am I in the right directory? Analysis. I may not be able to run this because I'm root. There you go. So you can log in and you can do stuff. And so that's actually a handy thing to know, that you can do that. And now when I exit from that and I go, it should have actually killed that Docker. So putting that //rm lets you kill that. The issue though is this isn't terribly useful to us as it is. Sorry. Because it won't let me write anything back. That's because I actually have a couple of problems there. I actually have two problems there. I have a permissions problem. So the directory that I'm in is not owned by the RStudio user. And I don't really want to change the username to something more. I want to change the username to something more secure in theory. So the example, hang on, let me just clear out some of these. So just to show you that example, and then I'll be quiet for a while and let you guys kind of ask questions, have a play yourself. But let me just grab myself those exercises. What I want to show you. Okay, so it's all well and good to write to the local container. Even if I could write to the container, it's just going to get data, my output data is just going to get stored in that data folder. So what we need to do, and we can do this at runtime. So we've built the image, and then you have a whole bunch of stuff you can do at runtime to control that. So if I run this command instead, is that big enough for people? I don't know how to make it bigger. Is that going to be too big? That's going to be enormous. Okay. This command here. So if I go docker run, so I've just used a little environment variable. This is in my own machine to set the data directory to be the data directory. run daemon, remove it when I tell you to properly, cleanly, map the port, give it a new name. This here will set the user ID to the right user ID. It will allow you to actually read and write and do stuff in there. You can set your password to whatever you want. So this little E flag basically lets you set a Linux environment variable. So you go -E, variable you want to set and value you want to set it to. So I want to set the password for my user to be so secret. And then this is the bit that's cool. This bit here, this -V, so that's mounting a volume. So what you do here is you say, see this physical directory on my machine, the data directory, mount that into the data directory that's in my container. So when I say that, basically it's the same as, you know, mounting a USB disk or something, but I'm mounting a physical directory on my host computer. So when I save something to that directory, it's back in the real world and we don't have to worry about like cats disappearing. Think of the cats. So this is the way to do that. There is a little bit of a subtlety in that for hopefully obvious reasons. I can't link multiple containers to the same directory because you could imagine the pain and suffering and apocalyptic doom that would happen if I could write to the same file from multiple processes. But you can write to, you can also hook it into write to databases or stuff. This is the easiest thing to do. And then I'm going to run this. So if I run this now, just to show you this example. Whoop. And I'm going to stop that old one because let's face it, and to check that it's stopped, I'm going to go docker ps. Right, so I've got nothing running. So now I'm going to paste. Oh, okay, sure. I was going to be clever. So secret. And what was the rest of it? -V. No. There we go. Let's put that to one side here. So it's so frustrating when you're used to working with like a giant high resolution screen and all of a sudden you're down to like the old days. So -V. And you do need a full path through memory. So I've set data directory. Hang on, let me just. All right, -V. They call it data dir / data. And I just data dir, and I'm going to map that to just home RStudio data. And it's the RStudio Hello World. Think that runs? Right, so now if I log into it, I should be able to. And either way, if this works or if it doesn't work, either way, I reckon we have a little break and do some exercises and get some coffee. How does that sound? So we can write. And if we look now back at, so in here, we go into the data directory, we've got our output CSV, you know, the most exciting CSV in the whole world, right? And if we go over here and we go, So, there are a few more little things and questions to work through on that exercise sheet. If you have that and you have it working, please just have a play, I think, for 10 minutes. And what we'll do is have a break for 10 minutes, do that for 10 minutes, have a coffee break, I think, for half an hour. If you have any questions, issues, whatever, we'll have a little bit of a thing after the break to do that. And then I'm going to, after the break, I'm going to do a couple more examples of things we can do and then some more play time, because I'm sure you all have your own examples of things you want to play with. So please, I'm going to de-mic for 5 minutes and wander around if anyone needs a hand with stuff. And then I think, yeah, coffee break is at 10:30. So keep yourselves entertained for 30 minutes. So yeah, some other things you might want to think of are, yeah, setting yourself up. The other thing that is useful is if you're testing out something and you want to make changes, you can make changes in your local machine and see them reflected. Change the username or password, Docker stop it. What happens if you want to run 2 versions of the container? Rebuild. Just have a play.